Hi there. A pleasant morning or evening or afternoon to each and everyone. So for today, I'm going to discuss to you logical operators. So logical operators in Java, we have and, we have or, and then we have not. Okay, these are the symbols that we will be using. So right here, the AND operator is these logical operators are also used uh, for certain expressions using relational operators. But this time, if you have two or multiple expressions within your conditions. But before we'll apply this one in a conditional statement or in a if condition. Let's try to understand them better. Okay, so let's start with the AND operator. So in the AND operator, assume you have here like num1 is equal to 2, num2 is equal to 4, and then we have num3 is equal to 5. Or let's say we will be using x, y, z. So x, y, z. Okay. So let's say for an instance, you are going to create an expression for like you have here first expression is x is less than, let's say x is less than y, and then you have here let's say x is less than z. Okay, so in this case you have two expressions. Okay, the first expression is it's actually implies that you actually get to compare x and y, which is the value of x is 2, and then the value of y is 4. And then the other expression is actually the other expression is x is less than z, which is the value of x is 2, and then we have less than z, which is the value of z is 5. So you have two expressions right here. The easiest way to read them is by number one, read this one first. The first expression is 2 less than 4. Okay, that's true. Oh, what happened? Yeah, that's true. And then another expression is 2 less than 5. That's true. So you have here you look for the operator that is used in this expression, and it says that it's AND. So you have here true and true. Okay, so you can actually look for the truth table of AND, but basically it's actually so easy to read this one. It's like reading this one as true and true. It's like let's say for an instance, there's a condition saying uh, from your girlfriend or boyfriend that he or she is going to marry you if you have house and lot. So basically the condition is you must have both. No, you must have both house and lot in order for her or him to marry you. So if you have house and at the same time if you have lot, that's true and true, meaning to say you are going to be married. So basically, the entire the entire expression says this is true, therefore the entire condition is going to be also true. So if ever you will be applying this to yeah, we can actually display this one. And then if ever you are actually going to make use of, like, you have here an if condition. So here you can have something like whatever whatever you whatever statement you will have right here, since you read it as true and true, and they end and you use and operator, and true and true is actually true in and operator based on the truth table. So that is why this statement right here will be executed. Okay, so what's that truth table? In your logic gates, for sure you have encountered this one. So it's like It's like this. Using AND operator, say you have X and Y, what's the result of that one? So let's say if X and Y, if this expression is true and the other expression is true, it means that the that one should be also true. And then if the first expression is true and the second expression is false, it means that the entire expression will be false. Similarly, if even if the first expression is false and then you have true using AND operator, though the second expression is true, you still have you will come up the entire expression will become false. So obviously, if you have false and false, then therefore the entire expression will also be false. So that's uh, the truth table of AND operator. In that's this one is actually introduced in logic gates. So this is similar to what we can actually do here in our program. I mean, let's try to do it. Like, let's assume that this is the first expression. This is the first expression. This is the second expression using these values x and 2. Let's say, let's start with x is less than y and x is less than, let's say, even if we do it like z is greater than x, something like that. So let's read that one later on, and then we'll have another one which is true and false expression. So true, you have here that one is true, x less than y, and we will have something like false here. So it's basically like that. And then let's have another expression which is false true. So we have, so basically we should have something like what makes this as false. Let's say x is greater than y. Okay, and then you have here, let's say z is less than, or z is less than or greater than or equal to x, and then we'll have false and false. So the false and false will have arrive false as the evaluation of this expression. So let's say this is false, and this one should be also like greater than. Say, let's say z is less than or equal to x. So let's, before we will run this one, let's have read this one first. So basically x and y, so the value of x is 2 and the value of y is 4. So is x, which is 2, less than the value of y, which is 4? So is 2 less than 4? So that is true. So the other expression is z, which is 5, greater than the value of x, which is 2, is 5 greater than 2? That's base also true. So the entire expression will be true because we use AND operator. Okay, so how about the other one? So you have here x is less than y. So x is less than y. 2 is less than 4. That's true. How about the second expression, z less than x? The value of z is 5 and the value of x is 2. Is 5 less than 2? Okay, so this is false. So this is the second, in based on our truth table, we have true, false. So true, false. So will give us false uh, output or evaluation of expression. Okay, so let's have another one. So x is greater than y. The value of x is 2. Is it greater than 4, which is the value of y? So is 2 greater than y? That's false. And then you have here and. So z is greater than x. The value of z is 5. Is it greater than the value of 2 or equal to 2? Yes, that is true. Therefore, this is still false rather. So because false and true is the third in our truth table, whether yeah, false, true, the entire expression is true. As long as there is, in using AND operator, as long as there is false, the entire expression will always be false. So similarly, you have here false and Z is 5, great less than or equal to 2 is false, and therefore you have false. That's the fourth in the truth table. So we can actually run this one. So we have true, false, 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 and that's how you do. That's how you read expressions. I mean, that's how you read a logical operator. So this is the first expression must be read first, the second expression, and then you what they call this one, you compare it to this one. Actually, we this one is if you're going to ask me, this one is also possible. Like this one here, it's like it's not going to, it's not going to care the it's not going to care the other side. Anyway, well, let's discuss this one in a separate topic. For now, that's how AND operator works. So logical AND is done like that. So how about logical OR? So in logical OR, you use the pipe operator. Yeah, is it pipe? Yes. Yeah, it's a pipe operator, and then you have here when using OR operator. The thing is that the truth table for OR operator is this one. So you have there true and true, that's still true. That is obviously true. True and false, that is true. So false and true, that is also true. False and false, that's false. So if you try to observe it earlier or before, when we use logical AND, so when there is false, no matter the other is true, no matter the other expression is true, it's always becomes false. So meaning, when let's say if there's condition saying, I'm gonna marry you if you have house and lot, but if you only have house and you don't have the lot, saan man ang lot, maglutaw-lutaw, maglutaw sa hangin. If you have the house and you have the lot, the only thing that is true to you is you have the house but you don't have the lot. So basically, false ang Picas expression. So therefore, you can't marry the person you love. So imagine if that is the condition, or that is the condition set by the person. And then if you have the lot and you don't have the house, you have the lot but you don't have the house for now. So still still there's other expression also that's saying that you don't have that one. Therefore it's still it's false. So false and true, you don't have the house but you have the lot. False and true, that means it's still false. So how much more if you don't have the lot, and at the same time if you don't have the house, obviously it's false. Now in the OR operator, as long as there is true in the expression as it is evaluated, everything or the entire expression will be true. So here in our truth table, as you can see, uh, it always becomes true as long as there is true. Okay, in the other side, in both or either other side, because it's or operator, or meaning I'm gonna marry you if you have house or a lot. So meaning either a house, or at least either a house or a lot. So it makes the expression as true because you have it. You either, I mean, you don't have both, but you have at least the house, although you don't have the lot. So it's still true, still valid. So similarly, if you don't have the lot but you have the house, that's still true. Okay, you have both, that's still it's very true. Okay, and what if you don't have any? Okay, that's false, of course. So because you don't have the house and you don't have a lot, it's a false. Okay, so let's change this to or statement. Okay, so basically, if we get to read this one right here, so upon reading, our compiler would read this as similarly, same, true, 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 false, false, true, false, true, false. But since we're using or, it's true and true, it's always true. true or false, that's this one becomes true. False or true means it's true. So assuming this is the house and this is the lot. You have the house or you have the lot, that's still true. You have the house, you don't have the lot, but still it's true because or. You don't have the house, but you have the lot, that's still true because you have still the lot or man. Sige. So you don't have anything. You don't have the house, you don't have the lot. That's not valid. So therefore that's false. So basically if we get to run our program, so here we are, you have true, 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 and false. So that's how you read using or operator. Now for logical not, which is represented by an exclamation point, it actually negates a certain expression. Example, when it is not true, it is false. When it is not false, it is true. It will just convert. The easiest way to understand it is when it is true, it makes it becomes false. When it is false, it makes it become true. That's not operator. So how is it done here? So we have here, let's say, okay. So based on our expression x and y, so let's say x is less than y, we know that x is the value of 2 and x is 2 and y is 4. Yes, the value is true. Okay, but if we are going to use not operator for this, so it is going to negate the expression. So what do you mean by it negates the expression? So if it not true, so it will now becomes actually false. So since this expression is true, it is being negated using the logical not. That true will now become false. Okay, so it's like asking, it's not, if it is not the house, it's the lot. If it's not the lot, it's actually the house, something like that. So and then you can also do something like using uh, let's say for an instance, you have here a not operator, and then you say something like you use something not operator in z less than x. Z, we have here, let's make this one ano muna. So you have here z, what was that? Z greater than x. So we negate the z greater than x. So basically our this time our and operator is, yeah, it's this one becomes false, and then you have the and operator, and then not, what's the value of this one? True. So not true, it becomes false. So basically this entire expression must be false also. Okay, so that's it. That's for not operator. Okay, so normally we use this not operator for, like, you have an expression boolean found is equal to true. Okay, let's say you do have something like if not found. So if not found, you have the uh, data, or the item is not found, because so if it's something like this, it's not true. So because found is the value of found is true, it's not true, it becomes false. So inegate niya. So the item is not found. So basically, uh, yeah, we have another statement. We should have another statement right here. So we have the item is if yeah, wait, if not let's say found, if not found, so the found is true, therefore it becomes false. So this one here is found, the item is found, the item is not found. So let's try. So since we have since we have here true, the item found is equal to true, it is being negated to false, therefore it will execute this not found. So just in case, along with the searching, you find the value and then you say something you find is equal to false. But initially your found value is true, and and after the searching you find something, and normally it is used for like in loop to stop a loop. So if it's found, therefore the found now will become false, meaning it's going to stop the value to stop searching the value. So meaning it's already found. So if not found, meaning since this is false, it becomes, so since this is like false, and then this will become true. So if not found, so which is false this time, because this would be followed, because this from from top to bottom ang reading, and then if not false it becomes true. Then since true ang expression, it will actually execute this block. So let's try. So we have the item is found. So similarly, that's the same thing you can do for or, like say for this one, if you want this to let's say for this one here, you can actually convert this into an if condition, and then you can now create a decision. Okay, so if you are able to read that one as true and true, and then it's good to, I mean, it's really easy for you to understand what you're writing. So it takes reading before you get to know, right? Before you know, it takes reading, or it takes time. I mean, it takes reading before you know how to write. So, di ba, when we were in elementary, we were actually taught to read first the alphabets before writing them, because we'll have to know how to read them. So, and then after that, the next step is we are going to write that symbol based on based on what we read, for based on how do we read that, or what or how we read A. Okay, and that's the time we can now write the A. Okay, so yeah, so that's how actually if if you are able to, if you find it like easy, you will also find it easier to write programs, because the moment you know how to read, it will be easy for you to write a program. But because when you code, it's not just coding is something that not just typing the codes, the program, or the instruction for computers to whatever you are going to write. It's because if you are just typing the code, it's not coding actually. Coding takes understanding, analyzing what you are writing, and typing is just simply typing without understanding you are writing. Okay, so what I can suggest to you is that you take time to read, you take time to look at some codes, and then try to read it before running them, and then make a comparable outputs, or make it like you get to compare before running them. You compare your output based on what you have read and based on what output you have come up, and then and after that run the program, and then if you have if you can beat now if you can beat the compiler, I mean, because you have the same output, that means there's an improvement of your compiling process. So you can become smarter. Uh, you can become smarter, similar to smarter than our computers, because you're able to beat the computers. But of course, computers are like compilers are actually built for that, no, for reading, and they can actually uh, give out or show off uh, result as faster as fast as that. Like in if we get to compare our the compilers like sa atua, of course, we have it takes process to come up with that output because we have to read it like line by line. So that's basically logical operators. Then if you are going to ask me, sir, pwede ba siya combination of and, combination of or, like you have here, and then unsay unahon, sir? Let's say you have z is uh, greater than, yeah, so this one will be really complex. So z is less than, so y is less than z. So that is uh, true. This is true. And then you have here another expression which says that you have here and then you have y and z. The value of y is actually 4. So we have 4 and then less than z, which is the value of 4 and 4 is less than 5. That is actually true. So what is now the result? So true, and is it true or false and true first? So that's something like unahon ba ni siya, sir, or unahon ning and operator? So in that if that's the case, it's para you it was confusion. So if that's the case, you actually read this like read like this. Now true in a from left to right. Okay, so you have here unless, okay, wait, unless you do this one later on. So true and false, that's actually true. And then the result of this one is true. True and true will make the expression, this expression true. So you don't read that, this one to be read first before reading or. So it's not something like that. The order of precedence is actually from left to right because they are in the order of, they are of the same precedence. Now, what if you have something like this one, sir, na sige, sige, compare na to. Let's say we are going to copy paste this one. So again, this is true. And then uh, you have here a parenthesis. So basically PEMDAS, no? So what should be read first? Is it going to be this one with the x, z, and no x? So it's obviously going to read this as, should be first, no? Read kanisila. So which is, um, this one is, the result of this one is true. Actually, same lang man di ay yapon, but yeah. So the result for z is less than x, which is 4, false and true. It's actually, the result of this one is false, and then true, or because we use or here, the result is still like true. Okay, so let's say, let's have, yeah, this is still true. So again, unahon ni siya ha, this one. So what if i iputang nato like this one is and this one is or. So this will be read first. Okay, then i-compare nato siya to like having no parentheses. So this is a true and this is false and false or true. This is basically or true, so still true. How about this one? This is and, I mean this is and pala, no? So this is and, so balikta. So this is false and false or true. That is the result of this is true because it has to be read first before comparing to and. So the result of this is true, true and true, it's still true. How about this one? True and without the parentheses. So true and false. So true and false, it's going to be false. False and true, it's still going to be true. So that's it. That's how you actually read when there is now a mix, operators or mix of logical operators. So also you can have mix operator like you combine all together. So let's say you have not x and y, sorry, or you can actually do something like you are going to negate the entire expression like this one. So basically, this should be negated. So this is not true. This is now becomes false. So false, false, and the result of this one is true, false, and true. This should be, I guess, yeah, it's false. And then if this is like conditional expression, so this will be read first. T and false. This is going to be the result for this one is actually true and false. It's going to be false. But since not false siya, this would become true. So basically, true and true is now true. So let's try if true gihapon siya. So uh, we have here what happened. I'm wrong with here. So ito lang yung tama. So let's get to check again. So we have you have here the uh, not true. Yeah, it's x. Sorry, it's x less than y, which is 4. So true, not true is false. Okay. And then after that, false and false is going to be like it's false. False and true is true. Yan. Nga naman di ay na, mali. So, false and false is false. But since there's or operator here, false, the result of false and false is false. But no matter false yeah, it's still true. It's still going to be true. So, the more you will have mixed expressions, the more it will become complex in especially in reading, no? So even ako na ano akong mata. Okay? So again, this is the same thing na pwede na itong apply sa atuang conditions. Let's say for an instance, say you can now use this one in doing range, no? So you have here if let's say age, so you have a int age is equal to let's say 10. So you have here like age is greater than or equal to 0 and age is less than or equal to let's say 20. So for this one the age is like say let's say for an instance age is let's say 1 na lang. Okay, and then you have here something like 17. Yeah. So you have also another, you don't have the and, but you only have one expression. Let's say if it's less than 0. So else if, so the output, the display for this one is age is, uh, I mean, sige, you are still a fetus. Tama ba? Okay. Okay, else if age is greater than or equal to 1 and age is, so there's range now that if age belongs to or in between 1 and 17, you can say something like you are a minor. So okay, and then you can have else if age is greater than or equal to 18 until let's say 59. So the more we do this AND operator, the more our program is a lot readable compared to single expression. So you are, let's say, you are an adult. And then you do also for, sorry, you also do for like any age greater than 60 up to 100. So you are a senior citizen. Okay, and then otherwise, if parang out of range, so we have here uh, probably dead. I don't know if that's okay, but probably dead. So we'll just assume. Okay. So you are a minor because it's 10. So if it's like -2, if the user inputs or enters -2, you are still a fetus. Okay. If let's say for an instance you have here 19, so probably this is how you will read it is 19 less than 0. So basically, in this expression, it's false, okay, because 19 is greater than 0. So it will now go to this and to other if statement, which is else if. So the expression here is if is 19 greater than or equal to 1. That's true, okay? So they have here also 19 is less than or equal to 17. It's false, okay, because 19 is greater than 17. That's and then we are using and, therefore this expression is false. Therefore it has to revisit the other block. So I mean it has to visit other block. So this is like age is greater than 18, so 19 is greater than or equal to 18. That is true. And age is less than or equal to 59. That's 19 is less than or equal to 59. That's true. Then our entire expression is true. Therefore, this will be executed. So it will display an adult. You are an adult. So yeah, you are an adult. So let's say we have 15. So this one here is false because 15 is not less than 0. And then 15 is greater than 1. That's true. Is 15 less than age? That's true. So therefore, the entire expression is true. So when you run this, since this one is the true, this block is the true, it will display you are a minor. So that's how you actually read, no? Let's say we have here 195. So it's false here, and then it's going to be also false right here because false age is less than 95 is less than to 17. So this is true here, but it's false right here. Age is less than or equal to 59. Yeah, so this is like false because 95. So this is false, and then here you have true, and is 95 less than to 100 or equal to 100. That's true. Therefore, the entire condition is true. So it will be going to display you are a senior citizen. So if ever now you have 195, that's a lot of age, no? So sana all. Okay, so basically false for this black, false for this one, false for this one, and also false for this one. And you have here, so it's going to be parang it doesn't. You don't have the choice but to execute the else statement. So you are a senior. I mean, the program will display something like probably dead. Okay, so that's basically an application of and you can also do in ors. For or, it's actually or yeah no. Basta for or is normally used for if you get to compare either when the user enters, let's say, either in between, let's say, character A, capital letter A or small letter a, that's the same thing. So either or, the user enters lowercase a or capital letter A. Okay, so for password, you must use and because the username and the password should actually match. So something like that's actually something that you can do for this one, no? If the username is equal to this one and the password should be equal to this one, so both must be true in order for you to log in successfully. If one is not true, then the entire expression will be false because you use and operator. Okay, so for everything you do, I mean, for this one, you can actually convert this to other way around. Like if you don't want to use and operator, you can actually do that by simply, um, let's say this one. No, you can actually remove. You are a minor. You can actually do that. Something like less than or equal to 17, less than or equal to 59. So and less than or equal to 100. So yeah, basically, if all age less than to 0 are still a fetus, all age up to 17 going to from 0 to 17, that's you're still a minor. And then age from 18 to 59, that's an adult. And then if the age is going to from 60 going to 100, that's still a senior citizen. This time you don't use an operator. And let's say if it's the same. So yeah, so I guess it's the same. So let's say we have let's say you have 67. So yeah, this is you are a senior citizen. Yeah, it's still the same. So only that the other one is the other one is a little bit readable compared to this one. Well, this one is a little bit it's a good, this one is a nicer solution compared to the other one, because this has if in terms of the reading process, no, sa when our compiler reads it, it's just going to read uh, one expression. Okay, remember, it's just going to read one expression, so therefore it doesn't have to read two expressions. So this one is a lot faster in terms of the efficiency now of the solution. So this is a efficient one compared to the other one, because the other one is it has to read the two comparisons or the two expressions before knowing that the entire expression is actually true or actually false. While this one is actually, it's just going to read one expression, and then it can now recognize that if that is true, it's going to display that certain execution. But then again, in terms of writing programs, as for now, you can actually, if you are able to provide different solutions, or you are able to come up with different solutions into one problem and then choose the best one, that is actually good. No, the lesser that it should be our mantra or our lingua franca, that the lesser the code, the better. And it means lesser, it means it will require less space. At the same time, it will require uh, less time in executing our program. So that's basically the essence of programming. You just don't create programs na I have here my solution and it's a lot better because I have it more lines of codes compared to yours. So it would be better if you are able to lessen your codes, so as it will only requires a small amount of time and space in your uh, in terms of time and space complexity, which is that will be discussed in data structures and algorithm of analysis. So I guess we call it a day today, and thank you guys for watching my videos, and uh, have a great day, and see you guys soon, or see you guys to our next session. Bye bye.